Before starting the teardown, gather the following tools. You'll need some sockets 2 1/8 inch, 19 millimeter, 17 millimeter, 12 millimeter. You also need the ratchets and an air gun in order to use these sockets. Open box wrenches in 10 millimeter, 12 millimeter, 17 millimeter, 21 millimeter, 23 millimeter. Also a 19 millimeter would be handy, and an 8 millimeter stud puller. Also a pilot bearing puller, alignment dowel pin puller, and a very healthy rubber dead blow hammer. Some small screwdrivers and putty knives can be very useful for removing gaskets, small parts, and for cleaning. We'll start with disassembling the engine by removing the flywheel. You will need an air gun with sufficient torque to remove the 2 1/8 inch nut. After removing the nut, strike the flywheel on the outer edges just inside the ring gear with your dead blow hammer. If you want to use a 5-pound steel hammer, be sure not to strike the ring gear, clutch disc surface, or the pressure plate mounting surfaces. 1 or 2 solid strikes should be enough. Do not strike an automatic counterweight the same way. Instead, use a cold chisel placed behind the counterweight at its smallest radius between the weight and one of the bolts on the rear gear. Knock the counterweight off by driving the chisel toward the shaft. Make sure you use a chisel thick enough not to hit the shaft or the inside of the counterweight. It would be a good idea to put the nut on a few turns to keep the weight from jumping off. The best time to pull the pilot bearing out is while the shaft is contained in the engine, like right now. We then rotate the engine to begin working on the front, removing the main hub bolt with a 19 millimeter socket. Pull the thermal pellet out and its spring. Now it's the easiest time to remove the main seal. Then remove the 12 millimeter front cover bolts. Each of these has one lock washer and one flat washer, and they will be needed when reassembling the engine, so save them. With a screwdriver or pry bar, gently lift the front cover from its gasket. With a 10 millimeter box wrench, remove the oil pump bolts. If you like, this would be a great time to remove the 17 millimeter nut on the oil pump gear. Remove the timing gear and lift off the oil pump and its chain and gears. Then remove the front counterweight. Remove the 12 millimeter gear bolts. Pry the thrust plate, in-play bearings, race, and spacer off. Put one of the front gear bolts back in to hold the gear in place. Then remove your water pump studs with the stud puller. Working from the back of the engine, remove the rear main seal and the woodruff key. Note that these bolts are shorter than the front gear bolts. Remove the long through bolts with a 17 millimeter socket. These bolts are also sometimes referred to as tension bolts. Don't forget to get the 2 bolts that are outside the circle. Using a hefty screwdriver or pry bar, lift the rear end plate at this location. Placing a screwdriver between the end plates and the rotor housings could damage them. Lift the rear end plate straight up, being careful not to make contact with the shaft threads on the rear main bearing. Lift the rear rotor out and collect all of your small pieces that remained in the chamber or fell off the rotor. Use all of the threads on the dowel pin puller for removal of the alignment dowels. Note the lower pins near the exhaust are usually more difficult to remove. Don't be surprised if it takes some effort. With the 2 pins out of the rear rotor, tap the rotor housing with a dead blow hammer to get it loose, and then remove that rotor housing. Pull out the remaining 2 dowel pins in the same method you used the first 2. With a large screwdriver or pry bar, lift the center end plate until it's loose. Carefully lift it off the shaft. Note that you may have to lift the shaft up a couple of inches to get it to come off the shaft properly. After your center end plate is out of the way, pull the shaft straight up, clear of the engine. Careful not to drag it along the bearings. Now take the front rotor out and collect all of your small pieces that may have stuck inside or fallen off the rotor. Tap the front rotor housing to remove it. And then take out the front gear. Remove the outer and inner water jacket seals with your tools. Small screwdrivers work real well. Take out the oil pressure regulator, pop out the rear main gear, and remove its old O-ring, because you're going to replace that when you rebuild the engine. When picking apart the rotors and their seals, don't worry about tracking the location of each part. Most of the seals are very similar in size and may need to be replaced anyway. Use caution when handling these parts. They are very sharp and may cut you. Be sure to get the springs and all of the carbon out from under the side seals. A local auto repair shop may allow you to clean parts with their solvents. You may also purchase cleaners from an auto repair or auto parts store. Remove the oil pressure regulator from the bottom of the front cover. Be sure to keep the spring and the plunger that came out. On the oil metering drive, remove the clips, the pin, and the gear from the shaft. Then push the shaft straight out of the cover. For cleaning the parts, a local auto repair shop may allow you to clean parts with their solvents. You may also purchase cleaners from an auto parts store. 200 grit sandpaper and a flat block is very useful on the sides of the rotor housings and the end plates where the rotor housings touch. Also, be sure to remove all old gaskets and flat block these areas so that they're nice and flat and clean. Do not recommend using orbital sanders for cleaning these areas because it rounds off the areas and the gaskets won't stay in place. Before you start the assembly, lay out all of your clean parts. There are 4 different oil ring springs in each engine. This one is the front-facing outer spring, which means it goes on the front face of both rotors. This one is a rear-facing outer spring and may have a blue paint mark on it. This is a front-facing inner spring with a white mark. This is a rear-facing inner spring with a blue mark. The colors on used springs may not be visible. Each oil ring spring has a round and square tab on its ends. The square tab locks into a square opening on the bottom of the oil rings. The round tab locks into round holes on the rotors. These are designed to keep the oil rings from spinning in the rotor. Here are your 4 cleaned outer oil rings and your 4 inner oil rings. At Atkins Rotary, we manufacture our heat-treated apex seals out of a material that is malleable enough to seat rapidly and work hardens without becoming brittle. This will allow better compression, better mileage, and more power. Here is a set of Atkins 2mm 2-piece apex seals with short and long Mazda apex springs. Unlike other aftermarket apex seals, ours are precision machined so that the tips are interchangeable. You will need 12 side seals and 12 side seal springs. You will also need 4 outer oil ring inserts and 4 inner oil ring inserts. We make these inserts out of Viton because they can handle a lot more heat than silicone. We've been using the Viton oil ring inserts for over 20 years in all kinds of applications. These are cleaned stock Mazda corner seals. Be sure to clean all the carbon out of the round hole in the center. This is what the cleaned corner seal with a new insert should look like. Here we have 12 stock wire corner seal springs, but we often use these 12 corner seal springs because they are stronger for high performance applications, especially where there's a lot of boost involved. These are the 12 rubber corner seal inserts. Another upgrade to the corner seals are these Atkins designed 2mm solids that don't need the inserts that often burn out under boost or nitrous applications. Be sure to clean every part of the rotor, especially side seal slots, corner seal holes, oil ring slots, and apex seal areas. Install the oil ring inserts into the oil rings. Use a screwdriver to straighten the seal. Sometimes you can use your fingernail too. This will ease the installation into the rotor. It is important not to use a sharp object because it may cut the seal, causing an oil leak. With the rotor on the left gear up and the rotor on the right gear down, we are now going to install all the forward-facing oil control rings and springs. You will now pick up your white oil ring springs and with the round tip on the right hand side, place the round tip into one of the little holes in the rotor. With the outer ring spring, place the ring opening as far away from the inner ring opening as possible, making sure the round tab is placed into its hole. Liberal amounts of petroleum jelly on the inside and outside of the oil ring will make the job easier. Each oil ring has 2 of these square depressions which will be placed on the square tab facing up on its opposing spring. We use a piece of wood that's been sanded smooth to help with the installation of the oil rings into the rotors. At this point, keep on pushing down carefully on the ring, walking around the ring until you feel it seat. The outer ring is more difficult to install. Be careful you don't slip because it may cut you. Install both rings in both forward faces of the rotors. Flip the rotors over and install the rear-facing oil ring spring. Hold the blue springs with the round tab facing down in your left hand. Make sure that the round tab sets down in the rotor in one of the round holes in the rotor. Then when you put your oil rings on, make sure that the square tab sticking up engages one of the square holes on the back side of the oil ring. Here is where the round tab on the spring should be placed. There are 2 round depressions on each rotor. Choose one. There are 2 square notches in the back side of each oil ring. One notch must line up directly with the square tab on each oil ring spring. As you did with the front face, press down carefully until each oil ring seats. Place small amounts of petroleum jelly in each corner seal hole and side seal slot. This will keep the seals from falling out of the rotors when it's turned over. Place your corner seal springs in each hole of the rotor, making sure the opened end is toward the apex seal slot. Note that there is an upper and lower side to the corner seals. The upper side is usually more polished and sharper than the lower or spring side. If you're using used corner seals, never install them upside down because they may never seat correctly. Make sure each seal freely moves up and down. Make sure you install side seal springs with both ends facing up toward the seal. If you decide to reuse side seals, make sure the shiny side faces up away from the rotor, because the spring side will have small grooves on it that may never seat properly. New side seals need to be trimmed to fit. Be sure to polish the end at an angle to match your corner seal. Before flipping the rotors over, put a little more petroleum jelly on the corner and side seals to keep them from falling out. At this point, we are now back to the front faces of the rotors. Install the corner seals and springs and side seals and springs the same way you did on the rear side. Stand the rotors up and place petroleum jelly in the apex slots. Install your apex springs with the tips facing up. Next, place the apex seal in the slot, making sure that the springs engage in the bottom of the depressions in the apex seal. The pointed end of the apex seal needs to point to the rear face of each rotor. Extra petroleum jelly will keep these apex seals from falling out. Check the seals for free travel without binding. Rotate the rotors and continue to install the remaining apex seals and springs. This particular engine uses 2 springs per apex seal. Some engines may only use 1 spring. Apply petroleum jelly on all your rotor bearings. One trick we use to help hold the apex seals in place until we are ready to install the rotors is to wrap an old black water jacket seal around it. If you don't have any extra ones, a rubber band may work. Be sure to check the clearances on all the parts. Parameters may be found in the Mazda Tech manual or the info sheet provided with this tape. The original 3-piece apex seals have been known to beat the slot open at the top of the rotors. Be sure apex seal slots are not spread out at the top. This may cause the 2-piece apex seals to fracture lengthwise. At this time, Mazda no longer offers 3-piece apex seals. We recommend that you lay out all your cleaned parts to make sure nothing is forgotten during the rebuild process. Clean the through bolt threads and underside of the heads thoroughly. A wire wheel works real nice. Inspect the in-play bearings and races for chipping and pitting. Examine the gears for broken teeth. Be very certain the Woodruff key does not fall out during installation of the gear on the oil pump. Make sure the shaft does not have any scratches in the bearing areas. Polish the bearing surfaces with a Scotch-Brite pad by hand. Be sure to blow out any dust or debris that may be in the shaft. Discard the shaft if it has ever experienced a bearing failure. A bluish discoloration is normal due to the original equipment manufacturing heat treating process. You will need these parts for your front cover except for these 2 keys for the main shaft. Remove these parts from your overhaul gasket kit and make sure that you have the correct quantity of each. At Atkins Rotary, we compression test every engine with the Mazda compression tester. We also pressurize the cooling system so that we know there are no internal coolant leaks. Starting the final assembly, we begin with installing the pressure gauge over the water pump housing opening. No need to worry if you don't have these tools handy. Slip the front stationary gear into the end play, making sure to align the pin with the slot. Take the thickest of this size race and lay it down in the gear. Note the inside bevel is placed toward the gear. Install the first in-play bearing and apply some oil. Set the largest race in place. Note that there's a pin that it needs to line up with. Of the gear bolts available, these bolts are the long ones, near 1 inch long. The shorter bolts are installed in the rear gear. Follow the torque specs provided by Atkins or your Mazda Tech manual. Turn the end plate over and apply a bead of Hylamar to the water jacket seal grooves. When installing the inner water jacket seal, place the joint at the top of the engine near the intake port because this is the coolest part of the engine. Somewhere in this area is the best place to install this joint. When installing the outer black water jacket seal, be careful that they don't twist or roll on you. Prior to 1986, this black water jacket seal did not have white sides. If it rolled or twisted, it was very difficult to see. However, you can feel it by lightly passing your fingers over the entire seal. Lay the other end plates out and repeat the process of installing the water jacket seals. Apply petroleum jelly to the surface of the cast iron end plates and bearings. Apply Hylamar to all 4 oil galley locations in the rotor housings and install the O-rings. Slide your alignment dowels into the rotor housings. Be sure that this alignment dowel is very clean inside because it doubles as an oil passage. Blow air into the oil metering orifice near the top of the rotor housing, making sure that plenty of air passes through. Apply a thin layer of petroleum jelly to the inner surfaces of both rotor housings. Install the coolant drain plug at this time with a new washer. Remove excess Hylamar from the end plates, which may clog the seals in the rotors if left there. Apply a thin layer of petroleum jelly on all surfaces. Flip the center plate over and repeat the process. Apply a few drops of oil in the oil pressure regulator. Check that it is not binding by pressing down on the plunger with the screwdriver. Install and tighten it into the rear end plate. It's best to do this procedure before you put the end plate on. Install 2 O-rings in the oil filter stand and bolt it down to the rear end plate. At this time, we place our oil filter on its mount to keep the oil system clean. A little oil on the O-ring will keep it from binding. Assembly of the front cover starts with the new main seal. You may use the pulley hub to keep the front cover in place for the remaining procedures. Another helpful hint from Atkins is to use a sharp punch to tap small dimples on the gasket surface of the front cover between the upper two bolts. This will keep the gasket in place. We have never had a front cover gasket moved from this location since we started doing this about 20 years ago. Lube the oil metering pump drive shaft and install it in the front cover, making sure it spins freely. Blow air into this orifice, making sure the passageways are clear. These parts will complete the oil metering drive. Tap the C-clip in place, insert the pin, slip on the gear, and install the second C-clip. Be sure both of these C-clips are securely in place. The next item is the oil pressure regulator. Lube the plunger and install it into the bottom of the front cover. Install the oil line adapter with a new washer, making sure it's snug. Each front cover bolt must have a flat washer and a lock washer. Prep your rear gear by installing a new O-ring, which is included in the overhaul kit. Apply petroleum jelly on the bearing surface and a new O-ring on the front main bolt. Finally, we are in the last stages of assembly. Apply RTV black to the oil galley area and the legs on the lower portion of the end plate. Another Atkins helpful hint: if you don't apply sealant to these legs, oil will seep or wick between the metal-to-metal finishes of the end plates and rotor housings. Put the front rotor housing on and install the front rotor gear down. With a small screwdriver, push the apex springs down on each apex seal. Install the apex end pieces. Make sure they get on top of the springs. Set the shaft down into the rotor and the front main bearing and give it a little twist back and forth to make sure it feels right. Place RTV black in these areas. Raise the shaft slightly and lower the center end plate. Tip the end plate slightly so that it can slip over the center of the shaft. Seat the center end plate on the front rotor housing. RTV the legs and oil galley on the center iron here. Install your rear rotor housing place your rear rotor in gear up. Once again, push the apex springs down to seat the apex seals and install the apex seal ends. RTV the oil galley and legs. Install the rear end plate. Apply RTV around the rear gear mount. Slide the rear gear down, being careful not to harm the bearing with the threads on the shaft. Align the rear gear slot with the pin. Install the 6 short gear bolts and tighten to specifications. Place your tension bolt seals at their locations. Spray a lubricant such as WD-40 or AMSOIL MP on the through bolt threads and underneath the head. The one bolt with the Mazda symbol is the longest bolt and is placed here. Torque the bolts down in stages in a cross pattern. When installing the rear main seal, do not use any lubrication. Install the rear woodruff key with a light tap of the hammer if needed. For this particular engine, we will show you the results of the compression test. At Atkins, we compression test every engine we build. At this time, install the flywheel or rear counterweight and Loctite this nut at 350 foot-pounds. At Atkins, this is the method we use for checking if there are any coolant leaks. We usually leave the engine pressurized for 15 minutes or more. Now we'll remove the parts from the pressure test. Center the end plate bearing so that the spacer can slide all the way down. Place your next end plate bearing around that spacer and apply some oil. By applying more oil to the counterweight, it will keep the thin race from falling out. The oil pump driving gear goes down with the teeth facing the engine. This is the distributor driving gear with the largest bevel facing the engine. Drop the spring in the shaft and place the thermal pellet on top of the spring. Install the pulley hub and the main bolt in preparation for an in-play test. A great place to mount the meter for this test is on the water pump stud. We'll tighten the bolt to 60 foot-pounds of torque. Using a screwdriver wedged between the counterweight and gear bolt, we keep the shaft from turning. With the same screwdriver between the gear and counterweight, feel for in-play. The amount of in-play desired is 0.0016 to 0.0028. If the in-play reading is less than 0.0016, then replace the spacer with a thicker one. If the in-play is greater than 0.0028, replace the spacer with a thinner one or carefully sand this one down on a flat block. We are happy with the in-play on this engine. Now we will install the oil pump. Take the main bolt and hub off to do so. Pre-lube the pump. Set the chain on the driven gear, rotate the pump over and set it on the engine while you place the chain on the driving gear. Install the 4 bolts. Notice the key is not in the shaft at this time. As each bolt is tightened, spin the driven gear to check for binding. Install the key, making sure it engages the counterweight. A good chain won't rub excessively on this counterweight. Install the remainder of the water pump housing studs. Apply gasket sealant to this front cover gasket area. Install the O-ring and its retainer. Put on the front cover gasket. And set the front cover on the engine. Hand start all bolts before tightening any of them. Check to make sure the front cover gasket hasn't moved. Torque the bolts down. Apply lube to the hub where it comes in contact with the front main seal. And set it on the shaft. Apply petroleum jelly to the main bolt O-ring. Apply red Loctite to the first half of the threads. Make sure the main bolt has a washer staked in place or held in place by RTV. Apply RTV on the top part of the washer to seal the shaft and hub, otherwise you may have a nasty oil leak. Install the bolt and torque it to at least 60 foot-pounds. You may stick your screwdriver in between the counterweight and gear bolt to stop the shaft from turning while you torque it down. I am David Atkins. It's been a pleasure working with you. Thank you and so long.